Whereas the other illusion wasn't 2D. The other illusion, all you had to do was adjust the focus of your eyes. Here, you actually have to go around this optical illusion. Sometimes, ladies and gentlemen, you don't just have to go around the optical illusion. You also have to turn your world upside down. So, I guess what I'm trying to say is that, in my work, I've done a lot of research in this issue, which I'm saying what people see is not what they get. And just to illustrate, ladies and gentlemen, is that we were, this work that we did with eye tracking, and essentially we were the first group to do eye tracking. Where is the shopping trolley? Or online, where is the shopping trolley online? Where is the shopping trolley? On the, somewhere here. If you go on a Western website, the shocking trolley is always somewhere here. Why? Because if you do eye tracking studies, it has been shown that for Westerners, they scan the page like this, then they progressively scan it in smaller increments, and then they just scan like this. So it is obvious that the shocking trolley should be here. Of course, in Arabic scripts, it's inversed, and the shocking trolley is always here. Now, ladies and gentlemen, this is a frame of a video that we applied eye tracking to. And this is the same frame. At the top part, we applied a computational model of a human visual system. And we extracted so-called regions of interest, regions which the user finds interesting. This is the same frame with eye tracking data obtained. What does this show you? It shows you one very important thing, ladies and gentlemen. If you apply the human visual system, the machine, vision, and so on, what happens is, ladies and gentlemen, is it picks up the edges of the snooker table. And why is that? Because an edge is a boundary condition, there is a signal jump, and therefore it must be something interesting to the human eyes. However, if we do watch a snooker match, what interests us are not the edges. And what interests us are, the player, the ball being struck, and the balls which are about to be struck as well. So this shows us two things. This shows us that all these computational vision models, they overcompensate, because in a uniform world, the areas of interest are much larger than the actual areas of interest. And then we came up with the idea quite a few years ago of playing the foreground in high quality and the background in lower quality. Why? Because if you do that, you end up economizing, saving on resources. And that, ladies and gentlemen, a bandwidth constrained resource is very, very important. Now, the problem with humans, ladies and gentlemen, is that they don't know how to express, how to explain their conceptions of quality. Even if they think they know how to explain it, they don't have the vocabulary to do it. So therefore, we are very, very challenged by this huge gap between human perceptual expectations at the one layer and communication requirements further down. And what we did was, quite some while back, we applied a combination of analytical hierarchical process, fuzzy programming methods, as well as reinforcement learning, in order to map perceptual requirements at the application layer, to map them into communication requirements further down, in order to have an optimized transmission. So, ladies and gentlemen, the internet, the architecture, the protocol architecture, when it was developed because people wanted to send the file overnight. So when you send the file overnight, it's important not to lose data, but the time constraints doesn't exist. So it is loss intolerant, but delay tolerant. Most of the communications nowadays are delay intolerant, but delay intolerant, loss tolerant. So it's totally different ways of looking at the communication of data. So what we did was we basically said protocols are overcomplicated. We can tailor protocols at runtime and use artificial intelligence in order to build the most appropriate protocol stack for the current application that we are using. The problem we had in those days was that if you wanted to do this runtime, the computational power wasn't there. Okay. Let's go back. Whenever I'm asked again to give a keynote in a country, I try to come up with commonalities, something linking me with that country. And of course here, ladies and gentlemen, the first thing I did was I bought the Jordan Pass, and of course everybody knows about Petra, and of course the Jordan Pass gives you a few other sites, which is what you're supposed to be visiting. But what could make me and Jordan, or my culture and Jordan, further down? Well, the clue is in my name, because just like Romeo, I'm not ethnically English, I'm Romanian. So I was trying to find out, interesting things linking Romania and Jordan, which are also relevant to my keynote. So it didn't take me long, ladies and gentlemen, to find out this person. Her name is Sarah Benna. She is the owner and the head chef at a restaurant in Amman called Bait Sarah. And that restaurant, ladies and gentlemen, is one of the only, I think it's the only certified vegan restaurant in the whole of Jordan. And it is also the top 3 vegan restaurants in the world. So, Sarah Benna, father Jordanian, mother Romanian, lived in Italy, a few other countries, and does an amazing job of opening a top-rated vegan restaurant in Amman. I'm not vegan, by the way. Okay, just thought I make it clear. Now, of course, I haven't been there because this is breaking news. So, you go on the Instagram pages and you see, what they offer. So this is the offer, Romanian crepes in oven and the seitan chicken rack, and so on and so forth. Obviously, vegan chicken. And then you go further down and you see other little vegan hot dogs and so on and so forth. The problem, ladies and gentlemen, is that when we go to a restaurant, we eat not with our tongue, we eat with our eyes, we eat with our smell. And the last thing that the food we experience is the food entering our oral cavity. We cannot, these images in audio and vision do not convey the full sensory experience of visiting such a highly rated restaurant. So, what's happened recently is that there has been a proliferation of sensory devices. This is a simple programmable fan for haptic sensations of wind. This, ladies and gentlemen, is an olfactory device. It has 4 little fans, which you switch on and which you switch off, and then you can again program the rotational speed, the timings, and so on. This is a haptic vest which you wear, and then when you play games, it vibrates. The problem, ladies and gentlemen, is that the internet and communication, digital communications, are geared towards the audiovisual, whereas they can be enhanced, as I've said previously, with other types of senses, and not in an expensive manner, ladies and gentlemen. So, how many of you have actually seen a TV program and you realize that the speaker's lips are out of sync with the video? Yeah? The reason that happens is because, of course, intermediate synchronization, and it has been shown that if the intermediate synchronization is between -80 to 80 milliseconds, you're fine. People will still be fine. Outside of that, it gets annoying, and people concentrate on the audio. For media such as olfaction, smell lingers. When you have taste in your mouth, the taste lingers as well. When you have something airflow on your face, on your skin, you still have the sensation of lingering, of caressing on your skin, long after the touch has actually disappeared. So what we've shown is that for synchronization between these types of media and the traditional audio-video type of media, the boundaries of synchronization are much larger. They're plus or minus 18, as opposed to plus or minus 80 milliseconds, they are 2 orders of magnitude greater, between -20 to +20. But those sensory displays I've shown you so far were relatively primitive compared to what is on offer now. So this, ladies and gentlemen, is currently an advanced haptic jacket. And as opposed to the previous one, in which the whole haptic jacket was vibrating, this one will only vibrate in specific regions of the body. So in the upper abdomen, in the shoulder, in the upper arm, and so on and so forth, or indeed on the lower abdomen. So again, it gives you a much more localized feeling of interaction, and again, heightening the sense of experience. Now, we're going one step further. So this is a lady with a headset, okay? And what does she have here? Well, perhaps it's going to be a bit clearer if we look at this particular gentleman where he snaps onto the headset, and over there, in this container, you have 2 little fans, one for airflow, the other one for emitting scent devices. And this is a commercially available product, and the greatest compliment, imitation is the greatest form of flattery. So here you have my Jordanian student, ex-Jordanian, ex-PhD student, Anas, who has become very famous because I've used this picture a lot of times. Okay, and here this is work that we did with him wearing a head device, a head-mounted display. And over here, ladies and gentlemen, we actually think we have better type of olfactory device. Why? Because this little device over here is a conic device which can extend and retract and be guided towards the nose of the user. So this is actually an even better technological implementation, and we've written how we can actually implement such a device quite low cost and quite affordable, or, ladies and gentlemen, for a cost of less than 300 pounds, so around 280 Jordanian dinars, which is less than probably one can achieve if you really have the resources. If you want to go from 2.5K to 4K, don't do it. It's overkill, over-allocation of resources. And you'd never get those results if you didn't do user experiments. And that basically goes to show that for VR, with current technology, anything beyond 2.5K is really overkill, and it's just marketing. So here, this is the user's viewport, which is translated here when it's divided into tiles. So you show this region more or less at high quality, and this region at lower quality because the user will never ever look there, so it's a waste of resources to allocate full quality video over here. So what we then do is we map all of these sensory effects to each tile, so we know that for each tile we have a specific sensory effect. And then we also transmit this sensory effects matrix over a network to the receiver. And then we have our 5G packet scheduler. So what the 5G packet scheduler does, it allocates the available frequency spectrum to maximize the quality of service satisfaction. So the problem currently still is that we still use current schedulers and they are unable to adapt dynamically to runtime network conditions. So what we want to do here, following on from our earlier work, is to apply each time the scheduler that best matches the current situation. So what we do is we've phrased the problem as a multi-objective problem. And essentially you have a series of 3 requirements which are all clashing each other, more or less. So while you want to have a high bit rate of over 20 megabits per second, you have to have a very low delay of 10 milliseconds and a minimal packet loss ratio of 1 in a million. Now all of these, they are almost mutually exclusive. And this is when we start using stuff like reinforcement learning in order to do that. So you have obviously the scheduler space, and I'm not going to bore you too much with that. Again, we have a controller over here, and again, the controller you can choose between different scheduler types. And then you obviously have a reward function because you have to feed back how good the choice was. And what we did in our work was essentially we had 4 different types of schedulers. One which was geared towards bit rate, the other one which was biased towards delay, another one which was biased towards packet loss, and this one which was combining the best of all worlds using reinforcement learning in an actor critical network. So as you see here, for the first one, okay, so the first one is in green over here. So here for the first one, the results are best for this tower in green, to the detriment of all others, more or less, with the slight exception of here at very low bit rates. Over here, ladies and gentlemen, we have the second one, which is in orange. And again, the second one performs the best compared to all other schemes when you basically prioritize the delay. When you look at packet loss, the results are not that great. You have the blue bit over here, so we really didn't get good results for packet loss at all. But what we did get good results for was when we had the reinforcement learned actor critical network over here. And as you can see, the black tower over here outperformed all other schemes in terms of overall quality of service satisfaction. So I think that was pretty good and a pretty positive result for using reinforcement learning. Now, I said at the beginning that people have very big problems explaining how they assess quality. And also, I also said at the beginning that computational vision models based purely on mathematical modeling are poor because they overcompensate. So what a lot of my colleagues are doing is they are looking at how large language models can be used not only for visual quality assessment, because they can do that with mathematical models and they're not that great, but for visual quality assessment for using human input into it. And not only that, to actually do explainable image quality assessment. So to be able to explain why a particular image or a particular video was rated in a particular manner. So this offers, I think, exciting opportunities. And what we have here is work recently done from colleagues of mine from the Nanyang Technological University in Singapore, and he is one of my collaborators, is Professor Y.C. Lim. And essentially, he tackles two very important problems. One is the overall quality explanation, and as I said, this one is not at all straightforward. And also, to answer on an attribute-wise level, microgranularity, why is that image rated in a particular manner? And of course, the way that large language models work and machine learning works is it's actually very great at solving conflicts between various criteria. So essentially, in the visual prompt tuning to dynamically adapt to visual features for the two tasks. And this, I think, is absolutely an amazing. I will end with some future directions currently being but they are currently being explored. Now, the big problem, ladies and gentlemen, in terms when you talk about olfaction, is that it's not color. It's not red, green, and blue. Olfaction cannot be standardly decomposed into 3 orthogonal different dimensions. Olfaction, there are different models of olfaction, but they are lossy models. We have different tolerances to olfactions. So the first thing is obviously to use the power of large language models to recreate olfactory spaces. It's extremely important. We can also use large language models to preserve our heritage. Why? Because a lot of our heritage is intangible. The smell of my mother's cooking, the touch of that particular material on my skin. We cannot recreate these digitally currently. However, if you input into an advanced artificial intelligence system requirements for recreating lost smells, that would be amazing. If you pick up a recipe book, ladies and gentlemen, from not even 100 years ago, from 70 years ago, what is the great bit of that recipe book? Apart from the fact that most of those recipes will probably be forgotten by now. The great thing about that recipe book is that most of the ingredients were locally sourced. Being locally sourced ingredients, it means that the carbon footprint goes down. So again, this is a very, maybe not your obvious way of using artificial intelligence and machine learning to reduce carbon footprint. So that is an amazing thing. It enhances sustainability, it improves the ability of local producers to supply the food chain. This is an amazing thing. Also, if I go back to the restaurant, to Bite Sarah's restaurant, I have a look at the menu, and then I can automatically create the smells associated with that menu from that textual description. That would make me want to go and visit Bite Sarah. That, again, ladies and gentlemen, is a very, very interesting way of applying analytics. Currently at Cornell, we are really interested in this concept of hyper-personalization. Now, personalization, ladies and gentlemen, has been around for a long time. Tailoring the content to the person's characteristics has been on the cards for a lot of years. What we are currently doing is we are modeling the problem as a very objective optimization, accommodating many individual preferences and differences at the same time, or in an ethically sensitive manner. We also have collecting sensorial metadata from a variety of sensors from the users, and we are applying all of these methods in order to hyper-personalize the multi-sensory user experience. And what we are doing, we are applying two quite radical algorithms. One is the grid-based evolutionary algorithm, and the other is the shift-based density estimation method, which were pioneered at Cornell, to conflict and resolve requirements which sometimes seem contradictory. And we are then, we are doing a lot of work in multi-sensory extended reality. And as opposed to the time when I was doing runtime adaptable communications, here we have the possibility to do this adaptation in runtime. And it has the potential to do quite radical results in what we are going to be experiencing in the Internet of the future. So, rounding off, I hope I've given you a flavor of what multi-sensory extended reality can do. I hope I've given you a flavor of how we can apply, and we are currently applying, artificial intelligence and machine learning to enhance the experience of users in this brave new extended reality world that we might be perceiving in the future. But of course, all of these applications are mostly at the, all of these future are mostly at the application layer. But ladies and gentlemen, it really is an end-to-end vision. If you think about the capture, production, distribution, rendering chain, and authoring chain as well, there is a lot of work to be done on exploiting, leveraging artificial intelligence and machine learning to optimize, to solve conflicting requirements, to to explain quality.
Okay, George.
Thank you very much.
Thank you for the presentation.